Hi everyone. In this method, I'm going to solve a optimization on simplex method. So the question is, maximize z is equal to 5x1 4x2 subject to 6x1 4x2 is equal to 24. x1 plus 2x2 is equal to 6 minus x1 plus x2 is equal to 1. x2 plus x2 is equal to 2. These four equations are subjected to slack variable to this z equation. So this is slack 1, slack 2, slack 3 and slack 4, where x1, x2, s1, s2, s3, s4 is greater than 0. This all s1, s2, s3 are the slacks associated with the respective constraints. Now z is equal to 5x1 plus 4x2. By tabulating a simplex tabular column can be represented as simplex w can be represented as cb basic variable cz by z is equal to x1, x2, slack 1, slack 2, slack 3, slack 4 and the constant, right? Means z constraint, not constant, z constraint. Is we should write the slack variables s2, s3 and the respective basic variable. Here s1 is 0, 0 s1, 0 s2, 0 s3, 0 s4, right? So 0 with respect to constraint, this all are zeros, and this x1 is 5, 4, 0, 0 and 0, and this x constraint, s1 constraint is x1 is 6 and x2 is 4 and 1, s1 is 1, 0, 0 and the constraint is 24. 1, 2, 0, 1, 0, 6 minus 1, 1, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, that is 2. This is row 1, row 2, row 3, row 4, right? Non-basic 0 S4 is equal to 0, 0, 1, 0, 0, 0, 1, 2. This is basic variables. S1, S2, S3 and S4 are the basic variables. Now to find Zj, Cb into minus Caij, that is 0 into 6 plus 1 into 0 into 1, 0 into minus 1, 0 into 0, we get 0 is equal to 0. And the same 0 into 4, 0 into 2, 0 into 1, 0 into 1, 0, 0, 0. Do it for all the things, like 0 into 1, 0 into 0 for all the things. Now get 0, right? To get the constraint Zj minus Cj, to which number we have to replace, means 0 minus 5, 0 minus 4, 0 minus 0, 0 we will get. And we have to take like to attain the optimization solution, we have to take the which is a 0 and more than 0. It should not be a negative number, right? So in this we have to take the highest negative number, that is minus 5, and from this we get a pivot column. To this ratio have to be find out. Ratio like 24 divided by 6 to the respective column, and now 6 by 1. Now take the ratio with respect to their pivot column, like 24 by 6, 6 by 1, 1 by minus 1, minus 2 by 0. This is infinity, ignore, minus, ignore, and this is 6 and this is 4. take the minimum value. This is minimum value, right? 4, and that element is called the pivot element. Respective pivot column element is called pivot element. And these are row 1, row 2, row 3 and row 4. Now replace the leaving variable in the basic column with the entering variable, right? The comparison are applied in the preceding table in the following manner. That is, replace this one, this is minimum now, so I have to replace s1 with the x1 variable. This is x1, right? So replace s1 in the basic column x1. This is the minimum number we have, ratio we have got, right? And that respective pivot column element x1 variable is 6. That is called pivot element. You have to make this 1, right? Where we have replaced s1 with the basic element x1. This has to be replaced, and this whole row should be divided by 6, because to make this as 1. Now same cb cz z is equal to x1 x2 s1 s2 s3 s4 z constant ratios, right? s1 should be replaced by x1, and in that constant z is equal to 5. Again same as usual, s2 s3 s4 0 0 0 z x1. You have to make this as 1, so divide this whole row by 6, right? That is, whole r1 is equal to r1 by 6. That is 1 4 by 6, that is 6 by 6, 4 by 6, 1 by 6, 0 0 0, 6 by 6 1, 2 by 3, 1 by 6, 0 0 0. Constant is 24, 24 by 6, that is 4, right? Same as usual. And to make r2, this column as 0, like 1 has to be replaced by 0, so 1 has to be replaced by 0, so that is r2 minus, you have to divide this 1 divided by 6 pivot element, and this is pivot column x1 variable, and into r1, right? With respect to row 1 we are dividing 1 by 6, so we get the value of this is 0, that is 1 minus 6 by 6 into 1, so 1 minus 1 is equal to 0. Next 2 minus 1 by 6 into 4, like it will become 2 za 3 za, 6 minus 2 4, 4 by 3. I hope you are getting. This is 4 by 3, same as usual, 1 by 6 1 0 0 2, same, this is same like r3 is like now r3 minus 1 by 6 into r1. This is the formula to apply for the third row, and this will be like 0 5 by 3 1 by 6 0 1 0 5. Same r4 minus what is that, 0 by 6 into R1. That same R4 value only we will get, right? 0 1 double 0 triple 0 1 2. Now to find the ZJ is equal to CB minus AIJ. What we will get? We will get 5U, 3.3, 0.83, 0, 0, 0. Because 5 into 1 plus 0 into 0, 0 into 0, again we will get 5U. 5 into 2 by 3 plus 0 into 4 by 3, 0 into 5 by 3, 0. We will get same. 10 by 3, that is 3.3. 5 into 1 by 6 plus 0 into minus 1 by 6, 0. We will get 0.83. Same like that only. So, now ZJ. We will get 5 minus where we left, right? Sorry. 5 4 triple 0. 5 minus 5, 0. 4 minus, sorry, 3 minus 3, 3 minus 3 minus 4, we get minus 0.7, minus 0.83 minus 0, 0.83, 0 minus 0, 0 minus 0. Now, negative value, to attain optimization, this one, solution, there should be a non-negative, non-zero, right? Here is a negative value, that is this has the greater value, minus 0.7 in the x2 variable, right? So 0.7 should be the pivot column, right? Now this is the pivot column. To take the ratio, divide z constant number with respect to their pivot column element, right? Ratios are 4 divided by 2 by 3, 2 divided by 4 by 3, 5 divided by 5 by 3, 2 divided by 1. What will get? 4, 1.5, 3 and 2. This is minimum. So S2 should be replaced with x2. S2 variable should be replaced with x2, non-zero variable, right? I hope you guys are getting. So column x2 is the pivot column, and this will be the key element or key column. Now by replacing h2 variable, same as usual method, cb cj z is equal to x1 x2 s1 s2 s3 s4 z constraint ratio. Same, x1 is equal to 5. Now x2 will be 4. Same as usual, s3 s4 0 0 x1. Now in this will be the pivot element. Pivot element is 4 by 3. To make this one, divide x2 by whole this 4 by 3, like 0 by 4 by 3, 4 by 3. 4 by 3 is equal to 1, minus 1 by 6 is equal to minus 1 by 8. 1 divided by 4 by 3 is equal to 3 by 4, 0 0. This will be as usual 1.5. I hope you guys are getting. Now row 1, row 2, row 3, row 4, right? For x1, for row 1, To make this element as 0, right? To make this element as 0, that is row 1 minus 4 by 3, sorry, 2 by 3 divided by 4 by 3, 2 by 3 divided by 4 by 3 into R2 with respect to R2. So what it will happen, R1 minus 3 get cancelled, 1 by 2 into R2 is the formula. So apply the same, again it will become 1 because R1 is 1, 1 minus half into 0, like 1 minus half into 0 is equal to 1. Next this is 0 and this is like another one, 1 by 6 minus half into minus 1 by 6, right? This will become 1 by 6 plus 12, 3 by 12, that is 1 by 4, sorry 1 by 4. This is minus 1 by 2, 0, 0, 3. Same as usual, S3, R3, sorry S3 or row 3, R3 minus 5 by 3 divided by 4 by 3, R3 minus 5 by 4 into R2. As usual, we get 0, 0, 3 by 8 minus 5 by 4, 1, 0, 2.5. Same, now R4. R4 minus, what is that? R4 is 1 divided by 4 by 3 into R2. R4 minus 3 divided by 4 into R2. We get 0, 0, 1 by 8 minus 3 by 4, 0, 1. This one will get R4 is what? 2 minus 3 by 4 into R2, 2. 2 and the 2 2s are 4 minus 3 by 2, 3 by 2, 1.5. 1.5. Now, I hope you guys are getting. Now, to find ZJ, 0, 5 into 1, 4 into 0, 0 will get 5, and 5 into 0, 4 into 1 will get 4. Same if you do, then we will get 0.75, same 0.5, 0.00. Now Zj minus Cj is equal to Cb. 5 minus, sorry, I forgot writing this. 54000. 5 minus 5, 0. 4 minus 4, 0. 0.7 minus 5 is equal to 0.75. 0.5, 0.00. So there is no negative value, right? So optimum solution has been reached. The optimum solution has been reached. So now 0 is greater than 0. So optimal solution is reached. X1 is 3, X2 is 1.5. So Z is equal to 5x1 plus 4x2. 5 into 3 plus 4 into 1.5. Z is equal to 21. Over.